good day everyone. This is Marvin Pidakan for our final exam in our core subject, Microprocessor, Microcontroller System and Design. So today I will be demonstrating a live sensor graph in our GUI based on the data acquired from our Arduino sensors. So here is the circuitry. So as you can see, there are two Arduinos. One is the transmitter and the other one is the receiver. So in our transmitter, here is the connected potentiometer to mimic the sensors for temperature, humidity, EDS, and the pH level. Also, we have here LED for indicators, LED 1, LED 2, and LED 3. And we have here also the fan connected in the L293D or the motor driver. Then we also have here in our transmitter the LCD, which will display the states for these peripherals, the LEDs and the DC motor or the DC fan. Then on the other hand, for the receiver, we have here only the LCD, a 16 by 2 LCD. So it will display here the values that we acquired here from our sensors. It will be transmitted via serial communication of these two Arduinos. And also we have here the virtual terminal for debugging purposes, and then a COM-PIN to connect this on the physical serial monitor of the Arduino IDE. So for our codes in the Arduino, so here for the receiver, we include the important libraries here. Then we declare the LCD, for example, and then the important variables temp, humidity, pH, and TDS. So here, what will happen here in our loop, it will check if the serial is available or if there are data on our serial. Then this process buffer, it will be the dem the demodulation of the data will happen here. We will be looking for the comma separated values that are sent via the transmitter. Then serial print, will be printed on our serial monitor on the virtual terminal on the Proteus. Then print LCD. So next we have here our transmitter, the code for our transmitter. We also include our the library needed for this program, then sensor, and some peripherals. So in the void setup, we initialize here some important, for example, the pin mode for fan 1, fan 2, then the LEDs. Then we set here them at low. Then we begin the serial here at 9600 baud rate. Then at low, we will read the sensors. Then LCD print here. Then we have here some conditions that are set on the given problems. So when the temperature is greater than or equal to 30, then the fan 1 and the LED 1 will be high. Also, it will display the states on the LCD. Then if else, it will be low. Then for pH value, if it is less than or equal 7, then LED 2 and the fan 2 will be high, else will be low. Then for humidity, the humival, when it is greater than or equal to 30, the LED 3 will be high, else will be low. So let's go back to our circuit in the Proteus. So as I simulate this circuit, so as you can see here, monitoring system, and our LCD when it is powered on. So here in the virtual terminal, so this virtual terminal belongs on our transmitter, and this other virtual terminal belongs on the receiver. So here, the comma separated format is sent by this transmitter via serial communication, and this receiver, once it receives I have programmed to print this on the serial, the received data. Also in our LCD, it will be displayed here. So as I vary the value for the temperature sensor, as you can see, becomes 38. Then for the humidity, I increase, becomes 80%. Also, you will notice here, when the temperature is greater than or equal to 30, the LED one and the fan one will be on. Also on our LCD, the states of the fan one and the LED one is on here. So as I decrease the value for the temperature, so fan 1 off, LED 1 off. So here the LED 1 is off and the fan 1 is off. Then when we decrease the value for the humidity, so when humidity is greater than or equal to 30, it will be on. So since it is lower than 30, then LED 3 will be off. Then when I vary the value for the pH level, so I increase the pH level, it becomes 9. So when the pH level value is less than or equal to 7, it will be on. But since the pH level is 9, it will be off here. So now I will show you my GUI. So in our program here in PyCharm editor, I use Python Plus for web frame of the web page. So now our GUI is live here at our local host. So when I click this, we will see the water quality monitoring system. So you will notice I have changed my title here. It becomes water quality monitoring system because I have based it on the parameters that we will be monitoring here for the temperature, pH level, humidity, and the TDS for the total dissolved solution. So these values are from our Arduinos. So let me just split my screen, then just this. So 28 for the temperature, and then 20 for the humidity, 9 for the pH level, and 3000 ppm for the TDS. So now I will vary these sensors. So for the temperature, I will increase it to 32. So in our web page, it is updated here, becomes 32 degrees Celsius. Also, you will notice here in our live graph, this data is increasing as I manipulate this sensor. So from 34 it becomes 36. Also in our temperature here, 36 degrees Celsius. So when the humidity, I increase the value for the humidity, becomes 60%. So for the humidity, it increases to 60%, and then increase it again to 70, becomes 70% here, then up to 100% for the humidity. So at 100%, then I will decrease the value for the humidity. Oops. Also, for the total dissolved solution, I will decrease the value by varying the sensor. So it becomes 2703 ppm. So you can see here. So in our graph, we'll also updated here 2703. As I decrease it, becomes 2102 here. So pH level, I will decrease the pH level. So you will see here pH level at 7. So decrease it again. So pH level at 4. Then the TDS, I will decrease the TDS for 1202. So we will also look at our numerical value for this. receive data. So it is accurate based on the sensors and in our web page. So let's focus here on our GUI. We have here our water quality monitoring system, the numerical value that we receive from Arduino sensors, then our graph, live, our live graph or the real-time graph based on the received data from our Arduino sensors. Also, I add here so you can download this graph as you desire. So we have here the PNG file, JPEG or a PDF document or SVG vector. So I will try to save it as JPEG image. So it will be downloaded and let's open this. So our graph is displayed here for more data visualization. So that is all for my final exam and thank you everyone.